Alright, so today we're going to be covering Einstein's two postulates, or parts, of special relativity. Einstein's face here really kind of says it all. If I had to interpret this, it would be like, you'll never understand special relativity. But my goal today is to help you understand the two basic foundational principles that led to special relativity today as we know it. So, what is relativity? The first thing we need to know when we're speaking about relativity is what we're studying, what we're trying to understand. In physics, when you hear relativity, you might immediately think of special relativity or remember that you were taught about special relativity. Relativity refers to the study of how different observers measure the same event. Now, I know what you might be thinking. Truth isn't relative, it's absolute. And that has some merit in some fields. However, relativity would argue that the truth can be different based on people's point of reference. Here's a philosophical example for you to chew on for a bit. You say that the weather is perfect outside, but your wife might say that it's chilly. Obviously, you're both experiencing the same temperature outside, but her response is of, it's cold, and yours is, no, it's not. Who's telling the truth? Well, you're both telling the truth, but you're both experiencing the same thing or interpreting the same thing in a different way. And so while the temperature is one thing, due to the point of reference between the two people, the answer to what's it like outside might be different. So if we know relativity is studying the difference between two observers' recordings of an event, the difference between general and special relativity is simple. In general relativity, the observer is accelerating. In special relativity, the observer is unaccelerated, meaning they're moving at a constant speed, or they're in an inertial frame. We'll get into this a little bit later, but for now let's just leave this as the difference between the two cases. Now, Einstein came up with two foundational postulates, sort of a scientific assumption, that changed how we viewed relativity and practically created special relativity. Okay, before we talk about the first postulate, it's important to understand what an inertial frame of reference is. So you know when you first accelerate in a car, you feel the force of the car pushing you back in your seat as it's picking up speed. But then, after a while of driving in a straight line at a constant speed, it's just like you were sitting on your couch back at home. This is a prime example of an inertial frame of reference. An inertial frame of reference is when you're moving at a constant speed and in a constant direction, meaning that there's no acceleration, and so inside your little system of inertia, it feels like you're at rest. This inertial frame stays the exact same until a force acts on it, causing it to either accelerate or decelerate. Okay, so keep this in mind as we move on to Einstein's first postulate. So Einstein's first postulate is all about frames of reference. So I included a little optical illusion. One person may see a duck, and the other might see a rabbit, or you might be able to see both. However, no matter what, it's the same picture. The first postulate says that the laws of physics are the same and can be stated in their simplest form in all inertial frames of reference. So think back to what we just talked about with what an inertial frame of reference is. Einstein is saying that the laws of physics are not changing between one person's frame of reference and another. For example, a plane that's moving at a constant speed and altitude will exhibit the same laws of motion as a car moving at constant speed and altitude. Both of these would be inertial frames of reference. Simply stated, this means that an object or a body in motion will stay in motion with constant speed and direction until acted upon by another force. Think Newton's first law here. Physics are always easiest in inertial frames. They become much more complicated when objects are rotating or accelerating. So anytime we are dealing with special relativity, we'll be assuming an inertial frame of reference. This just keeps something that could be really complicated a little bit more simple. Alright, so the second postulate of special relativity has to do with the speed of light. And the speed of light immediately makes me think of traveling through space. And this isn't too far off. The second postulate says that the speed of light is a constant, independent of the relative motion of its source. This means that two observers would both see light traveling at the same speed, regardless of their motion relative to the source of the light. For example, the Earth orbiting around the Sun. Regardless of the Earth's orbit around the Sun, the speed of light is constant. This was proven by the Michelson-Morley experiment, but no one could explain why it was the case until Einstein came around. Einstein, seeing a contradiction between Maxwell's laws and Newtonian laws, decided that no object with mass can move at the speed of light, and that light doesn't need a medium to travel through, hence the constant speed in a vacuum. However, this doesn't mean that the light will move at this speed through any medium. Light is slowed through mediums such as water and glass. So, if you were wondering why these things matter, here are a few things that came about directly from these postulates. The discovery that mass can be converted to energy and vice versa, E equals mc squared, became a hugely important idea for concepts like fusion and fission. Length contraction and time dilation, with objects moving near the speed of light, or at very high speeds, became very important in the effects of space travel. Many things regarding how we see and perceive things today were able to be deduced through Einstein's understanding of special relativity. So I know this sounds pretty complicated, but here's a little video to kind of sum up how physicists feel about this.
And that's the way, we like it. All together now. That's the way, we like it. And that's the...
So it seems complicated, and that's because it sort of is. But hopefully after this presentation on the two postulates of special relativity, you have a little bit better understanding of what special relativity is and why it's important.